Hello and welcome. Now that you've been introduced to high availability concepts and how they work on OCI, let's see how we can apply that to an existing scenario. In this walkthrough, some sequences will be played at fast speeds, not necessarily reflecting the actual time that it takes to perform those operations. The initial scenario consists of two instances. The first instance is in a public subnet, and it will hold the web server for WordPress. The second instance is on a private subnet and it hosts the MySQL database. The first step I will do is to move the web server files to an NFS share. The file storage service provides a managed NFS service that is highly available. To create a file system, go to the navigation menu, select Storage, then click File System under the File Storage area. Click on Create File System. I will start by editing the name and making the name something that is meaningful for my environment, so I will call it WordPress. The export path is the name of the share. If you try to list the NFS server, that's how the share is going to be identified. If I had a mount target, I could be selecting to reuse that mount target. In this scenario, I don't have a mount target, so I will create a brand new one. The name of the mount target is something that is used to identify it within the OCI console, so I will make something that is meaningful to me. I will then select the VCN where my components are, and then I will select the subnet where I want that endpoint to be placed. In this scenario, I will use the same subnet that the database is using. It's a private subnet because I want the NFS share to be isolated. We will skip the Use Network Security Groups at this moment because the Network Security Group was not created yet. Now it's time to create the Network Security Group. Go to the navigation menu, select Networking, Virtual Cloud Networks, pick the VCN that it's in use. On the VCN, select the Network Security Group, and let's create a new security group. To limit the access, we will use another network security group as the source type. We already have a network security group that is used by the web servers, and they will be the source that we will select. Access to file storage service requires TCP and UDP ports. Those ports are listed under the Security section of File Storage Services. You can enter multiple ports at the same entry, and when you create the rule, they will be split on separated rules for each port. Now that the network security group was created, you can go back and in the mount target edit and include the network security group. With the share created, it's time to connect to the web server and transfer the files to the NFS share. You can see the share using the show mount command on Linux. That will ensure that you have the proper access to the share and you will be able to mount it. At this time, we will mount on a temporary location to transfer the files. Here I mounted the NFS share on the MNT directory. On the NFS share, I will copy the HTML folder, the web server root directory. It contains the WordPress files and directories. When the command finishes, I check that the files were properly copied to the NFS share. Now that the copy is finished and verified, I will mount the folder. Stop the web server, rename the www folder, recreate the www folder empty so it can be the mount point for the NFS share. Now with the new www folder created, I can mount the NFS share on this directory. My Linux server is using SE Linux, so I will have to run a command to add the directive that allows the Apache server to use NFS shares. With the permissions corrected, now I can start the web server, then go to the web browser and make sure that my WordPress installation is working. Let me apply the changes that I did to the diagram. Moving the files to the file storage service is an easy way to ensure that they will be highly available, accessible to several web servers in a durable and reliable storage. Before adding more servers, let's add a load balancer that will distribute the incoming requests. Before creating the load balancer, I will create a network security group that will govern the access to the load balancers. I will go to the VCN that is being used by my environment, and on the network security group option, I will create my network security group. I'll be opening ports 80 and 443, HTTP and HTTPS respectively. Using the breadcrumb, I will click on Networking, and from this menu I will select the load balancer. On the load balancer screen, I will click on Create Load Balancer. When prompted for the load balancer type, I will select Load Balancer. On the wizard, I will name my load balancer. Make sure that it's a public load balancer, and I'll keep moving on the choices. For my environment, I can stick with the flexible shape of 10 megabits. I can change that later. I don't need IPv6 support, so it's time to select the VCN that I'm using and the public subnet where the load balancer will be placed. As I already created the network security group, I will go ahead and use the checkbox and select the load balancer network security group. On the next screen, I will select the load balancing policy. I will leave as weighted round robin. Then I will proceed to add backends. I will add the existing server until we create a pool of servers. The existing server will help to validate that we configured properly the load balancer. In my scenario, I'm not using SSL, so I will not check the box and move to the next screen. On the listener configuration, I will select HTTP as I'm not using SSL certificates. Advancing to the next screen, I will leave the default log options and submit to create my load balancer. The load balancer can take a couple minutes to be provisioned and another couple minutes to report properly the backend servers. Let's fast forward to the end of the process. With the load balancer in place, let's take a look on how the diagram looks. Along with the distribution of the incoming connections, the load balancer gives an extra layer of isolation. Now, I will create the instance pool and the auto-scaling policy that will adjust the pool dynamically according to the load. Before that, I will create another private subnet for the web servers. Because the load balancer is on the public subnet, I can move the web servers to a private subnet and keep them more protected. Remember that you should always consider the security best practices when designing your environment. Security counts to ensure that the environment will be highly available. I already have a network security group assigned for the web servers. I will edit and change the source type from CIDR to another network security group, the one already used by the load balancer. When I create the web service subnet, the app subnet, I will choose the regional type. A regional subnet spans across the whole region, encompassing all the existing availability domains. Moving resources from one availability domain to another in a regional subnet is simpler than when you have AD-specific subnets. The subnet is created, and now I will create an instance that will be the template for my instance pool. It will define the settings for the instances managed by the instance pool. This instance configuration will use a Cloud init script to install the required packages and make the required changes. Once the installation is complete, I'll double check that the instance is according to what I set on the script. I placed the template instance in the app subnet. So to access the instance, I will need to set up a bastion, or in my case, I will use the initial existing web server as my jump server. Check complete and ready to move forward and create my instance configuration. The instance configuration can be created from the details screen from the template instance. After creating the configuration, I will be directed to the instance configuration details. From there, I can create the instance pool. After setting the name of the instance pool, you can see that the instance configuration is already selected, and you can select the number of instances. I will leave as 0 for now. From this screen it is also possible to check the summary of the instance configuration. Advancing to the next screen, I will be able to select the availability domains that I want to be used with the instance pool. I will add all the 3 availability domains present in this region. After adding the availability domains, I will attach a load balancer to this pool. So whenever instances are created or deleted, that will be reflected on the backend set. After the instance configuration is created, I don't need the template instance anymore. Let me clean that up so it does not spend resources unnecessarily. After cleaning up, I will edit the pool and set it to 1, so the first instance of this pool can be created and we can test if our installation is working correctly. After submitting the change, the pool will scale up and the instance will be created. After the instance is created, I will check on the load balancer, and when the new instance report as healthy, I will edit the backend servers and remove the initial web server. Now it's time to use the public IP address of the load balancer and test our WordPress installation. Most of the work is done. Now we need to create the auto-scaling policy that will scale the pool up or down depending on the load. Adding a pool with an auto-scaling policy will ensure that any time that the load increases, the pool will respond accordingly and the application will always be up for the customers. As I'm planning to manage the pool based on the amount of resources used, I will pick a metric-based auto-scaling. For my performance metric, I will select the CPU and define the thresholds where the pool should scale out or in. I will also define the minimum, maximum, and the initial number of instances in the pool. After reviewing the parameters, I'm ready to create my auto-scaling policy. One more step down and 2 to go. Let's take a look on the diagram and see how it looks after adding the instance pool and the auto-scaling policy. At this point, we eliminated the single point of failure that it was a single server, and now we have a load balancer that distributes the load among several servers on the pool. The pool is elastic, responding to the increase of load and decreasing when the load is no longer present. The WordPress files are shared using File Storage Service. With all this taken care, now let's turn our eyes to the MySQL instance. Currently in my setup, MySQL is running on a compute instance. I will replace this compute instance by a MySQL DB system. A managed DB system simplifies some maintenance tasks and offers several features that otherwise would require manual configuration, like backups and replication channels. When I create a MySQL DB system, I have the choice of creating it standalone or highly available. I will start by creating it standalone, and down the road I will upgrade it to be high available. After setting up credentials, I will go ahead and configure the network. I will use the same VCN and also the same subnet that was in use by the initial DB system. I will choose the availability domain and the hardware shape for my system. After selecting the hardware, I will set up the backup plan and create the DB system. At the time of this recording, the DB system is not working with network security groups, so the network access will be granted at the secured list. After creating the secured list, I will use the initial web server to configure the DB system that we just created. I will create the WordPress database, I will create the user and grant the proper permissions to the WP user. After that, it's time to dump the current database to a local file. Once the dump is concluded, we will upload that dump to the DB system. After loading the dump, I will verify that the database was correctly populated. Now that the database was transferred to the DB system, I will change the configuration on WordPress to indicate that the database is on a different location. To ensure that the new database was properly configured on WordPress, I will stop the MySQL service on the initial server. After shutting down MySQL, I will go to the web browser, go to the WordPress site, and then log into the admin page. Logging to the admin page ensures that the WordPress is pointing to the correct database. After switching from the compute instance to the DB system, let's take a look how the diagram looks. The final step on this journey will be to change the existing DB system from standalone to high available. Setting up MySQL in a HA environment, it's not a simple task, but as we are using the managed service, with the click of a button, that is possible without any intervention. The system takes a while to provision the new instances and configure it properly. So we will use some fast-forward magic to go to the end of the process, and we will review all the changes that I made on my environment. When the DB system finishes updating, no change is required. The previous endpoint IP that my system had will become a floating IP. It will be used for the node that is active, and in case of that node has a problem, that IP will be migrated to the next node, and the database will keep working. And that's the end of our journey. Let's take a look of where my system started and what it became. We started with a WordPress system running on a compute instance, using a database also in a compute instance. The first step was to move the WordPress files to a shared storage. We used file system storage for that. The second step was to add a load balancer. The load balancer gives isolation and the ability to distribute the load between several servers. After the load balancer, we moved the web servers to a private subnet, and in that subnet we created an instance pool associated with our scaling policy. That would ensure that the web servers are up and running according to the load that comes to the system. The fourth step was to change the compute instance where MySQL was running to a MySQL Managed Database service. Using the managed service, we will achieve better levels of service, reducing the complexity and the maintenance overhead. Finally, we turned the MySQL DB system into high available. In the event of failure of the database system instance or the whole availability domain, replicas placed in other availability domains will ensure that the database keeps running. With that, we conclude this lesson. I hope you enjoyed the walkthrough,